In order for water to flow through the semi-permeable membrane, the water must be pressurized to a certain pressure using a reverse osmosis pump. Therefore, before water enters the membrane, it is necessary to ensure that there is sufficient water rate so that the reverse osmosis pump is always pumping water. If the reverse osmosis pump is connected to an electric power source but there is no water supply, the reverse osmosis pump will heat up and be damaged. Therefore, in this case, the booster pump is an optional equipment that can be installed or not depending on the water source.
Before the water enters the semi-permeable membrane, a filter must be used to remove sediment and chlorine from the water. The media used in this pre-filter stage varies depending on the size and type of solids to be filtered. In essence, this pre-filter media is very necessary because if it is not installed, the reverse osmosis membrane will work hard and will quickly become clogged with solid particles.
The first pre-filter array is a 1 micron porous sponge. Sediments larger than 1 micron are filtered out in this first pre-filter, while those smaller than 1 microns pass through to the next filter media.
The second pre-filter contains a granular active carbon cartridge, or GAC for short. GAC is made from high-quality coconut oil shell carbon. The GAC works by absorbing organic substances in the water, including pesticides and chlorine. So this GAC serves to improve color, taste, and odor.
The third pre-filters contain a chlorine test and odor cartridge or CTO for short. CTO is made from coconut activate carbon which is naturally processed through several stages like GAC. CTO works to improve the color, taste, and odor of water.
The fourth pre-filter housing contains the softer resin cartridge. The cation resin in the pre-filter system functions in the ion exchange process, with its primary function being to reduce lime or calcium levels in the water.
The fifth, or final pre-filter array, contains the ultrafiltration cartridge. This water purifier is capable of filtering out solids larger than 0.01 microns in size. After water comes out of the fifth pre-filter, in this state, the solids have been greatly reduced because they are filtered in the pre-filter system. In addition, the water quality has been improved in this pre-filter system. Therefore, the water is now ready to enter the reverse osmosis membrane system.
In order for water to penetrate the reverse osmosis membrane, a 3D6 DC reverse osmosis booster pump with a capacity of 800 gallons per day is required. This pump is equipped with a 5 AMP adapter. The pump function is to push the water that has been treated in the reverse osmosis pre-filter system.
To produce water with a capacity of 1,000 gallons per day, two units of type 3000 enter the membrane housing must be installed in parallel, which are filled with type 3013 reverse osmosis membrane with a capacity of 500 gallons per day each. The 500 gallon per day reverse osmosis membrane is capable of passing 500 gallon per day or equivalent with 79 liters of liquid per hour. This membrane is capable of filtering up to 95% solids.
To further ensure that the drinking water produced is in compliance with the applicable regulations in Indonesia, especially in accordance with Appendix Chapter 2 of the Regulation of the Minister of Health of the Republic of Indonesia Number 2 of 2023. Two samples were taken. First sample is a raw water before being treated in the reverse osmosis system, and second sample is a clean water product after being treated in the reverse osmosis system. The water sampling was done by certified personnel from Virsik Global Indonesia, so the water taken is really valid without any contamination. The housing membrane has two outlets, clean water and wastewater. The wastewater has a very high TDS content. For this reason, the wastewater from the reverse osmosis membrane should not be returned into the reverse osmosis system, as it will accelerate the plugging of the reverse osmosis membrane.
Water that comes out of the reverse osmosis membrane usually has a low pH or acidity level, tastes bland, bitter, and plain. For this reason, after the water comes out of the reverse osmosis membrane, it will flow through the Pusan system, which is useful for improving water quality as clarity, odor, taste, and pH.
The first biosense array is post-carbon. Post-carbon is used to give water a better taste. Without post-carbon, reverse osmosis water tastes bland and bitter.
The second biosense array is bioyellow, also known as bioenergy or bioceramic. This bioenergy is used to activate, purify, and mineralize water. The minerals add are potassium, sodium, calcium, magnesium, phosphorus, iron, and zinc elements, selenium, copper, strontium, iodine, fluorine, silicic acid, and 18 kinds of other trace elements necessary for the human body. Yellow ceramic can reduce chlorine in water and further change the acidity of water. The taste of water will be fresher and tastier when drunk.
The third array of biosense is bioinfrared. Bioinfrared can not only add the elements of zinc, lithium, iodine, and selenium that our body needs, but also regulate the circulation of microorganisms and enhance their immune capacity.
The fourth array of biosense is bioalkaline. Bioalkaline is used to condition water into alkaline water which has a pH of 7.
The fifth or last biosense array is Bio5-in-1. Bio5-in-1 is designed to activate water molecules, increase oxygen levels, and remove chemicals and toxins from water.
After the water comes out of the biosense system, it enters the ultraviolet tube, which functions as a killer of bacteria, viruses, and fungi. Ultraviolet light is a type of electromagnetic radiation used to kill microorganisms in water through the sterilization process. This process is highly effective and is considered one of the most efficient ways to rid water of harmful microorganisms.